This project is about image steganography. Image steganography means hiding an image within an image. So before starting with the project, the discussion, I would like to clarify some other terminologies. The first one is the image which is hidden is called the hiding image, and the image in which the hiding image is hidden is known as host image. The main aim of this project is to hide an image inside another image in such a way that uh, the hiding the host image as well as the container image looks almost similar, and also we should be able to reconstruct the hiding image from the container image. Let's see what all these terms mean is using the pictorial diagram. As you can see, this block diagram is basically a common representation of all the three approaches which are used to implement this project. The first one, this image is known as the host image. This image is known as hiding image. This is the container image or the encoded image, whereas this or this is known as the revealed or the decoded image. So the aim of this project is to hide this hiding image inside the host image in such a way that this container image, which is formed by hiding this image inside this, so this image and this container image should look almost similar. That is one of the main aim of the project. The second aim is that we should be able to reconstruct this hiding image from this container image. So the process by which we hide this hiding image in the host image is represented by this block merge, and the process by which we reconstruct this hiding image from this container image is represented by these two blocks that are region detection and unmerge. So we will look into all these terms in the next few slides. So to achieve the two goals of our project, we have three approaches. The first one is KLSB, the second one is based on FFT, and the third one is based on convolutional neural networks. So based on the approach, we choose which type of approach is necessary for implementation of a project, for hiding an image inside another image. We'll discuss it after we go through all these uh, approaches, and then we'll see the results of all these approaches, and then it will make a sense to choose the approach. The first approach is the KLSB approach. Uh, we know that an image can be considered as a multidimensional array in which magnitude of each of the cell represents the intensity of the color. This magnitude can generally be represented as an 8-bit binary number. So in this approach, we try to reshape the hiding image, the image which is being hidden inside the host image. We reconstruct that, we reshape it into a one-dimensional array, and then we we change the pixel values of it. We change the value of the pixels from decimal to binary system, and when we do it, we get a very long binary string similar to this, which is represented by this message secret, or basically the hiding image. The host image can also be considered as a sum of various pixels. Now those pixels can be represented as an 8-bit integer, 8-bit binary numbers. So each of these rows represent one of the pixel. Now to hide the image inside the host image, We take one LSB from the secret message or the hiding image, and then we replace it with the LSB of the host image. As you can see in this diagram, we take the first bit of the hiding image, we replace it with the last bit of the host image, and then we take the second bit and then we replace it with the last bit of the another pixel, and then we repeat the whole process. Now the main aim of the project is that the encoded image and the host image should look almost similar. Now we'll see how we make sure that both the encoded image and the host image looks almost similar. For that, let's consider, we know that that suppose the pixel value of the value of pixel or the intensity of color in the pixel is 225. Then we can represent it in binary as 11111111. Now suppose we replace the LSB of that pixel of that byte by 0, then it will be 244. So the change in the intensity of the color is just 1 by 255, and that change is so small that we cannot see from our eyes. So that is what we are actually doing in this approach. We are just making a small change in the host image, and that small change is not visible to our eyes, but while replacing the last bits of the host image, we have saved the information of the hiding image. So after replacing, we get the encoded image, and this is the output of the encoder, and this is the image in which we have hidden the information of the hiding image. Now for extracting the hiding image from this encoded image, we just do the reverse of this process. What we do is we collect all these last bits, the last bit, the last bit, and the last bit of each of the pixels of the encoded image. We then make a long binary string similar to the uh, string we used in the encoding, and then for reconstructing the image, we just reshape this whole binary string into an image. And that is how we hide and decode an image inside within an image using the KLSB approach. The second approach is based on FFT. In this approach, we use Fourier transform to hide the image. So in this, uh, for this approach, we consider the both hiding image and the host image as a sum, as a matrix that is concatenation of a large number of 2 cross 2 matrix, 2 cross 2 matrix sum like this. Now for hiding the hiding image, we first take one of the 2 cross 2 matrix of the host image. We take its FFT to change it into the Fourier domain. We add the corresponding values of the secret image or the hiding image in the Fourier domain, and then we take inverse inverse Fourier transform of the 2 cross 2 matrix, which is obtained after adding both these two cross 2 matrix, and the matrix which we get after the inverse Fourier transform, that matrix, when we repeat the whole process for all the 2 cross 2 matrix, that forms the hiding image, the container image, and that looks almost similar to the host image. As we'll see in the results, that the host image and the container image looks almost similar in the FFT based approach as well, and the same is the case with other two approaches. The third approach is the deep learning approach. In this approach, uh, we train a convolutional neural network to extract features from hiding image, and then we hide it in the host image to form the container image. The CNN model for doing this task is made of two models. One is encoder, which is represented in this first half of the model, and the decoder, which is represented in this part of the diagram. This encoder is used to hide this hiding image inside the host image to form the container image, and the decoder is used to reveal the image. Now the encoder uh, is is itself made of two networks. First network is the prep network, and the second one is the hiding network. And the decoder has just one network, that is a reveal network. In this approach, we the first network, that is the prep net, that network one is trained in such a way that it extracts all the features from this hiding image and it gives an output. The network 2, that is the hiding network, that concatenates the host image along uh, that concatenates the host image and all the features that were extracted from the prep net, and it concatenates it, and then it hides all those extracted features inside the host image to form container image. So this is first part of the project, that is hiding the image. Now after hiding, we have to decode the image. So that is the part of the decoder, the network 3, which is known as reveal network. This reveal networks uses a number of convolutional layers to extract the features of this hidden image from the container image, and then it reconstructs this hidden image, which is then known as revealed image. Now the encoder and the decoder both are trained simultaneously, which makes them exclusive to each other. This means that if the encoder is used to encode the hiding image in an host image, then the same decoder has to be used to decode the container image. So if we use a other decoder to decode the container image, then the reconstructed image might not look similar to the hiding image. And this feature gives us an extra layer of security and robustness. So now we have discussed all the three approaches: the KLSB approach, the FFT based approach, and the deep learning approach. So now we'll look into all the three, the results of all these three approaches, and after that we'll have a look at which approach is to be used for our application. Now, as you can see, the host image and the encoded image looks almost similar, and there are no visual differences in both these approaches. So we have established, so we achieved the first goal of a project, that is the host image and the encoded image should look almost similar. The second aim is to reconstruct the hiding image from the encoded image, and as you can see, the hiding image and the decoded image looks almost similar. So we have achieved the second goal of the project as well. For the KLSB approach, the hiding image and the decoded image are 100% same, and there is not a difference of even one uh, intensity of the color in both these images. As mentioned earlier, the number of pixels this hiding image is 1/8 of that of the pixels of host image. This is because 8 bits of host image is used to hide 1 bit of hiding image. And these are the results of the FFT based approach. As you can see in this approach as well, the host image and the encoded image looks almost similar, and there are no visual differences between both of them. So again, we have achieved one of the goal of the project. The second one, the second goal of the project is hiding image, and the decoded image should also look similar, and we should be able to reconstruct this hiding image from the encoded image. So as you can see, the hiding image and the decoded image are also look similar. For this approach, we should make sure that the hiding image and the host image are of the same size. So these are the results of the FFT based approach. The results of the CNN approach are as follows. As you can see again, the host image and the container image looks almost similar. So we have achieved the first goal of the project, and also we have extracted all the features of the hiding image from the container image. But as you can see, there is a little distortion in color of hiding image and the revealed image. So this is one of the drawbacks of the of this approach. So now the question is, if the results of the CNN network are not good as other approaches, do we even need it, or do we even use this approach? The answer is yes. Based on the application for which image steganography is used, the approach is decided. So the hiding and the recovered image in the LSB approach are 100% same, but there is a drawback to this approach. It's not robust. One of the reasons for using image steganography is to hide the presence of any hidden information. The simplicity of the LSB approach makes it harder, and the hidden image can easily be reconstructed by anyone. Thus, we look for the other approaches, the FFT based approach and the CNN based approach. The FFT based approach increases the robustness of the algorithm, but the hiding and reconstructed image have small differences. The CNN approach further increases robustness of the algorithm, but at the expense of a little distortion in the reconstructed image. So the approach of this project is chosen based on the application of the project, and that's all about this project. If you are interested in this project, please feel free to check our blog on image steganography and the GitHub repository for the code. Thank you.